There is a city that should not have been abandoned. By any reasonable measure of what cities are and how they work, Angkor should have survived. At its height in the 12th and 13th centuries CE, it was the largest pre-industrial urban settlement on Earth. Modern satellite imaging has revealed that its infrastructure extended across a region of over 1,000 square kilometers, a network of reservoirs, canals, rice paddies, residential areas, and ceremonial centers so vast that its full extent was not understood until aerial surveys conducted in the early 2000s began to map what the jungle had spent 5 centuries slowly consuming. The Temple of Angkor Wat, its most famous monument, remains the largest religious structure ever built by human hands. The hydraulic engineering system that sustained the city's estimated population of somewhere between 500,000 and 1 million people was, by the standards of the medieval world, extraordinary. And then, sometime in the early 15th century, it was gone. Not destroyed, not conquered in a final decisive battle that the records capture, not wiped out by plague or famine in a single catastrophic event. Gone in the way that is in some ways harder to explain than any of those things. Gradually, incompletely, and then suddenly completely, the city was abandoned. The hydraulic system fell into disrepair. The canals silted up. The reservoirs failed. The population dispersed, and within a generation or two, the jungle began its slow reclamation of structures that a civilization had spent 5 centuries building. For most of the period since Angkor's rediscovery by European scholars in the 19th century, this abandonment has been explained in political and military terms. The Ayutthaya Kingdom of what is today Thailand sacked Angkor multiple times in the 14th and 15th centuries. The Khmer elite eventually relocated the capital southward, toward what is today Phnom Penh, following trade routes that had shifted with the emergence of maritime commerce. The political explanation is not wrong. But it was always incomplete in a way that scholars sensed, but could not fully articulate. Because political explanations for the abandonment of a city of 1 million people on a working hydraulic system require an additional explanation for why the hydraulic system itself was allowed to fail. Armies can sack a city. They cannot, by themselves, cause a sophisticated water management infrastructure to collapse across an entire region over decades. Something else was happening. The first serious challenge to the purely political explanation came not from genetics, but from climate science. Beginning in the early 2000s, researchers analyzing tree ring records, lake sediment cores, and speleothem data from caves across mainland Southeast Asia began reconstructing the climate history of the region across the medieval period. What they found was a pattern of severe climatic instability in the 14th and 15th centuries, precisely the period of Angkor's decline, that had not been visible in the historical record, but was unmistakable in the physical archive of the natural world. The region had experienced a series of extended droughts interspersed with episodes of extreme monsoon flooding. Not the ordinary seasonal variation that the Khmer hydraulic engineers had designed their system to manage, something more severe and less predictable. A climate that was oscillating between extremes in ways that pushed an infrastructure built for a more stable regime beyond what it could handle. The reservoirs that were designed to store monsoon water for use in the dry season were overwhelmed by flooding, and then insufficient during the droughts. The canals that distributed water across the agricultural system became choked with sediment from the erosion that the extreme rainfall events caused. The rice paddies that fed a city of 1 million people began to fail not because the farmers had forgotten how to cultivate them, but because the water management system they depended on was being destroyed by the same climate that the system was supposed to manage. Researchers examining the physical evidence of the hydraulic infrastructure have found clear signs of emergency repairs made to canals and reservoir embankments during the late Angkor period. Repairs that used lower quality materials and less precise engineering than the original construction, consistent with a population that was trying to maintain a system faster than the system was failing and eventually losing that race. The scale of the infrastructure that was falling apart was staggering. The West Baray Reservoir alone, one of the largest human-made water storage structures of the medieval world, held enough water to irrigate the rice fields that fed hundreds of thousands of people. When the embankments of structures like this began to fail, the consequences were not local, they were systemic. And systemic failures in water management systems do not announce themselves in the historical record with the drama of a military defeat. They appear gradually, then catastrophically, in declining agricultural yields and increasing food insecurity, and the slow dispersal of a population that can no longer be sustained where it is. This is the climate story. And it is compelling, well evidenced, and now broadly accepted as a major contributing factor in Angkor's decline. But it is not the complete story, because here is where the genetics enter the picture in a way that nobody initially expected them to. A series of ancient DNA studies conducted between 2018 and 2022, analyzing skeletal remains from sites across mainland Southeast Asia spanning the Bronze Age through the medieval period, produced a picture of the population history of the region that complicated the story of Angkor's decline in a specific and important way. The Khmer people who built and inhabited Angkor showed, in the ancient genomic data, a genetic profile that was the product of a long and complex history of population movement and admixture in Southeast Asia. Their ancestry combined components from the original Hoabinhian hunter-gatherers of the region, among the earliest inhabitants of mainland Southeast Asia, with a substantial contribution from Austroasiatic-speaking farmers who had moved southward from what is today southern China during the Neolithic period, and additional influences from later population movements that the archaeological record had only partially documented. This was not surprising in itself. The genetics of mainland Southeast Asian populations are known to be layered in this way. What was more surprising was what the data showed about the relationship between the Gay Khmer population of the Angkor period and the populations that had inhabited the same region in earlier centuries. The genetic continuity was high. The people who built Angkor were not a population that had arrived from somewhere else and imposed their culture on existing population. They were, in their deepest genetic roots, the descendants of the people who had been in that landscape for thousands of years, and the modern Cambodian population shows strong genetic continuity with the Angkor period Khmer. The abandonment of the city did not mean the disappearance of the people, but embedded within the ancient DNA data from sites near Angkor, researchers found something that the climate records had hinted at but had not been able to confirm in human biological terms. The skeletal remains from the later phases of the Angkor period showed signatures of nutritional stress and disease burden that were elevated compared to earlier periods. Not catastrophically elevated, but measurably so, in ways consistent with a population under sustained environmental pressure, a population whose food supply was becoming increasingly unreliable, a population whose immune systems were being challenged by the disease conditions that typically accompany the flooding events that the climate data described. The genetics were finding in the bones of the people themselves. The human biological record of a civilization being worn down not by conquest, but by the accumulated pressure of a climate system that had turned against the infrastructure its inhabitants depended on. This is the twist that changes everything. Angkor was not abandoned because the Khmer were defeated. It was not abandoned because a more powerful civilization replaced them. It was abandoned because the machine that made a city of 1 million people possible in the middle of mainland Southeast Asia required a specific and relatively stable climate to function, and that climate had been replaced. Over the course of several decades in the 14th and 15th centuries, by something the machine could not handle. The political disruptions from Ayutthaya were real, but they were the final pressure applied to a system that was already failing. They were, in the language of systems analysis, the last straw on a structure that climate had already weakened to the point of collapse. What the genetics add to this picture is the human dimension of a story that climate science and archaeology could only tell in terms of infrastructure and rainfall patterns. The people who lived in Angkor during its decline were real individuals whose bodies recorded the stress of that decline in their bones and their teeth, and the isotopic signatures that researchers can now read from materials that have been in the ground for 600 years. They were not historical abstractions. They were people managing, as people always manage, a situation that was changing faster than their institutions could adapt to. They moved. They dispersed. They took their knowledge and their social structures and their religious practices and their genetic heritage southward and eastward into smaller settlements and eventually into what became the modern Cambodian nation. The city was abandoned. The people were not. The Khmer Empire was never simply what we thought. It was never simply a civilization that was politically defeated and replaced by stronger neighbors. It was a demonstration, played out across 5 centuries of extraordinary achievement and 2 generations of accelerating collapse, of how completely a civilization's survival depends not just on the intelligence and ingenuity of its people, which the Khmer possessed in abundance, but on the stability of the natural systems within which even the most sophisticated human engineering is ultimately embedded. The climate changed, the machine broke, the people moved. And the jungle came for the stones slowly, over decades and then centuries, until satellite imaging in the 21st century began to reveal the full extent of what the canopy had been hiding. The DNA is now reading what the stones cannot say. And what it tells us about the people who built Angkor and then left it behind is that they understood, at least in practice, if not in the abstract, something that every civilization since has struggled to learn in time. That the most impressive thing any people can build is not a temple or a reservoir or a hydraulic system that sustains 1 million lives. It is the capacity to survive the moment when what they built is no longer enough. The Khmer survived that moment. They dispersed. They adapted. They carried their culture and their genetic heritage into the settlements that became modern Cambodia, and their descendants are alive today, still building, still irrigating, still living in the landscape that their ancestors engineered and then had to leave. The city was not the civilization. It was an expression of the civilization, the most ambitious expression, the one that pushed the limits of what the available climate and the available engineering could sustain. When the climate withdrew its cooperation, the expression ended. The civilization did not. That distinction between a civilization and its most ambitious built expression is something the genetics now allow us to see with a clarity that the stones alone could never provide. The data is only beginning to tell us everything that survived the jungle.